Today we will do revision of the chapter Work, Energy and Power. In physics, work is used in relation to the displacement produced by a force, and hence is its definition. One important point to be noted is that the displacement is produced in the direction of force. The factors that affect work are the magnitude of force. That means the more the force applied, more is the work done. And the second factor is the magnitude of displacement. The more the displacement, again more is the work done. And hence the formula for constant force, the formula for work when force is constant is given over here. The SI unit of work is joule and is defined as the work done by an object when 1 Newton force is applied on it, which causes displacement of the object by 1 meter in the direction of force. The relationship between the SI unit and CGS unit of work is 1 joule is equal to 10 to the power 7 erg. Now here I would like to throw some light on one of the very important characteristic of work, and that is that work is independent of the path. In this figure you can see that A is the initial path and A is the initial point and B is the final point. And there are 3 paths shown in the figure. The length of these 3 paths are different, but if you calculate the amount of work done by the body on moving from point A to point B, it will come out to be same, doesn't matter what path the body has followed. Also, work is a scalar quantity, that means it is independent of the direction of the displacement. There can be certain situation or circumstances when displacement is not along the direction of force. For example, if a body is moving along a horizontal direction, this is the direction of displacement, but the force which is applied is acting in this direction F, such that the force and displacement are making an angle theta with each other, then the formula for work is given by Fs cos theta. Now this theta, which is the angle between force and displacement, can be acute. That means it is possible that the angle between the force applied and displacement is less than 90. In that case, work will be positive. If the angle between force and displacement is equal to 90, then work will be 0. And if the angle between force and displacement theta is obtuse, that means greater than 90 but less than 180, then work done will be negative. So let us see the 3 most probable situations. This is case number 1, when the direction of force and displacement are same and hence theta is 0 degree. Cos of 0 is equal to 1, and hence this is the condition when we get maximum work and the work is positive, because the theta value is less than 90 degree. An example is that of a freely falling body. Suppose a body falls towards the ground, that means the force which is acting on the body is equal to the weight of the body, and weight is acting due to the force of gravity, and the displacement is along this direction only, then the angle between them will be 0 degree, and hence it is the condition when maximum work is done. This is the next slide which shows you case number 2. In figure B of this slide, there is a person who is moving in this direction, and the weight that he is carrying is acting in the downward direction. That means the angle between force and displacement is 90 degree. Similarly, in the third diagram, in which the motion of a body is taking place along a circular path, you can very well observe that the angle between the force and displacement is 90. Displacement is the direction of displacement we find by drawing tangent at a particular point. So, if the body is suppose over here, then force which is acting in the inwards, that means along the direction, along the radius, and the displacement will be in this direction, both of them will make an angle of 90 degree. Hence we can say that at every point in this circular path, the angle between the displacement and the force is 90, and hence theta, which is 90, which will make cos theta equals to 0. And this is the condition when no work is done. Here in this diagram, there is a body which is moving, which is a satellite which is moving along a circular path. In this condition, for one complete round, work done will be 0 because the displacement will be 0. Whenever a body comes back to its original position, displacement is 0. But if I ask you that what will be the work done if the body has covered only half of the circle or quarter of a circle, that means still here, then what will be the work done? Then also work will be 0 because at every point on this circular path, at every point the angle between force and displacement is 90. So doesn't matter it covers the half of the distance or 1/4 of the distance, work done in a circular path is always 0. However, there is one more situation when work will be 0. If you remember, in the previous slide, there was a boy who was trying to push the wall. So in that situation also, work done will be 0 because there is no displacement taking place. Hence, work is 0 when there is no displacement or when angle between force and displacement is 90 degree, and one more case is that when there is no force applied on the body, when the force is 0. So these are the three situations when work done by the object is 0. Now comes case number 3. In this situation, you can observe that the direction of force is upwards while the displacement is downwards. There is another picture showing the same thing, that force is upwards and displacement is, the direction of weight is downwards and the displacement is upwards. Here I am considering the weight exerted by the body in the upward direction. That means only the weight and not the force by which the body is or the man is lifting up the object. If I consider the weight of the body in the downward direction and the displacement which is happening in the upward direction, then both of them are opposite to each other. So this gives rise to case number 3, when angle between force and displacement is 180 degree and cos 180 is -1. Therefore, this is the situation when you get negative work. But work is a scalar quantity, it cannot be negative. So definitely here negative sign denotes the angle between F and S. That means it says that force and displacement are oppositely directed. It has nothing to do with the direction of work because work is a scalar quantity. An example of negative work can be the work done against friction, or when you throw a ball up, then the weight of the ball acts in the downward direction but displacement takes place in the upward direction. So these are some more examples when you will find the work to be negative. So this is the entire description of all the 3 cases: negative work, positive work and zero work. And as explained to you that the work can be 0, negative or positive depending upon the angle. Now this is the next slide which shows the condition when work is done against gravity. In both the figures you can see either the man is lifting the object, like in this case the man is lifting the object and here it is being dropped. So in both of the cases the work is done and the body is moving either up or down. We know that work is force into displacement. Now when the body is being moved up or pulled down, the force is equal to force acting on the body is definitely its weight and the displacement is the height. So this makes W equals to mgh. So this is the formula which you will apply when the work is done against gravity. Here definitely we will ignore the negative sign. The next topic is energy and power. Energy is defined as the capacity to do work and its SI unit is same as that of work because both energy and work are closely related to each other. For example, if a man does 100 joule of work, then the energy spent by him will also be 100 joule. Some other units of energy are calorie, electron volt and kilowatt hour. Next is power. Power is defined as rate of doing work and the formula is work upon time. Therefore, power depends upon 2 factors: the amount of work done and the time taken. If a machine or a person does a given amount of work in less time, then more power is spent. Power can also be written as force into velocity. Both power and energy are scalar quantity. The SI unit of power is watt and 1 watt is defined as if 1 joule of work is done in 1 second, then we say power spent is 1 watt. However, there is another unit of power which is horsepower.